Okay, so we're going to look at a few more things with parallel and perpendicular lines. Again, you'll probably have to stop the video every now and then to write this stuff down. Okay, so let's look at the first one. Now, we want an equation in standard form. Okay, remember standard form, ax plus by equals c. So we don't start with standard form. We always use the point slope formula to write an equation of a line. Okay, so it passes through the origin. Okay, remember the origin, that's 0, 0. And it's perpendicular to this line. So I need to find out the slope of this line so I can get the opposite reciprocal. Okay, I'm going to put it over here. So I'm going to say 5x minus 2y equals 8. Negative 2y is negative 5x plus 8. Then I'm going to divide everything by negative 2. And I'm going to get that y equals a positive 5 halves x minus 4. Okay, so the slope of this line is 5 halves. But I want a line that's perpendicular to this line. So the perpendicular slope is going to be negative 2/5. Okay, so I have my point. I guess I'll put it over here. And I have my slope. Okay, so now y minus y1 equals m x minus x1. So y minus 0, that's just y. Negative 2/5 times x is negative 2/5 x. Negative 2/5 times 0 would be 0. So there it is. Oops, but that's in slope-intercept form. And we got to get it in standard form. Okay, so I always start with this form here. Okay, so standard form, remember, x and y have to be on the left. Okay, so I'm going to get 2/5 x plus y. Okay, so this was negative on the right side. It became positive on the left. Now, I can't have a fraction here, but it's just the denominator I can't have. I can have the 2, but I can't have the 5. So remember what we're going to do. We're going to multiply every single thing, and it has to be everything by 5. Okay, those cancel out, and I get 2x plus 5y is 0. Okay, so there it is. This is in slope-intercept form. This is in standard form. Okay, so let's look at another one here. So again, it's telling us what we got to get to standard form. And we need a line that passes through this point and is parallel to this line. Okay, so let's do part A. So x equals 3. Remember, that's our vertical line that crosses the x-axis at 3. This has a slope that's undefined. Okay, so if something's parallel, it also has to have an undefined slope. Okay, so I'm going to draw like a little picture to help me on this one. Okay, so it's going to go through 4, negative 3. Okay, so it has to be parallel to that, so it has to have an undefined slope. So, oops, it has to go like that. And this is the line, x equals 4. And that is in standard form. Okay, so there's that. Oops, you guys can't see it. And let's look over here. We want it parallel to this line. Okay, well, y equals 3. 1, 2, 3 looks like that. Okay, and this has a slope that's 0. So our new equation has to have the same slope because it's going to be parallel. Okay, so again, just like before, it's going through 4, negative 3, but this time it has to have 0 slope. Okay, so it's going to look like that. It's going through negative 3, so this is the equation, y equals negative 3. Okay, so that one you got to think about. what's going on there. Okay, let's look over here. Now, slope-intercept form, a line that passes through the same x-intercept as this line, and it's perpendicular to this line. Okay, so we're a little advanced here. We've got a lot of directions. Okay, so if I want the x-intercept, do you remember what we do? So if I want the x-intercept, I plug in 0 for y, solve for x. So I'm going to say x-intercept. I'm going to plug in 0 for y and solve for x. Okay, I'm going to subtract 6 from both sides. Divide both sides by 3. Okay, so that's my x-intercept right there. So when x is -2, y is 0. Okay, it's perpendicular to this line. Well, this line has a slope of -3. One that's perpendicular would have a slope of 1/3. Okay, so I'm ready to go. I've got my point and I've got my slope. So y minus y1 equals mx minus a -2. That becomes a plus. This is just y equals 1/3 x. Now, when I multiply 2 times a third, straight across, 1 times 2 is 2, and it's like there's a little 1 here. 3 times 1 is 3. Okay, and it said we could have it in slope-intercept form, so we're good right there. All right, last one. We want to determine whether the following, I shouldn't say graphs, I guess we could say graphs. Graphs are parallel, perpendicular, or neither. I guess we should say the following. I'm going to make that lines. Okay, so what we have to do is we have to find their slopes. So I'm going to call this line 1, line 2, line 3. So let's start with line 1. Okay, it looks like this. So in order to find its slope, I got to solve it for y. This is going to move over here and become positive. Divide everything by 2. Remember that the 2 doesn't go up. There's a 1 there. Okay, this has a slope of 1/2. Let's look at line 2. So we had 1/2 x minus y. Okay, this is coming to the right, so it's going to be negative. It's still not solved for y. It's solved for negative y. So everything by, we can still do it like that. So this becomes y equals, this is just going to be a positive 1/2 x, -7. So one thing you can see, like if you want to make this y a positive, you just flip all of the signs. Okay, so this has a slope of 1/2. And line 3, we have 4x plus 2y equals -10. This 4x is coming over. I'm going to divide everything by 2. So y is -2x minus 5. So this has a slope of -2. Okay, so we can see that line 1 and line 2, they have the same slope. They're parallel. Okay, so line 1 is parallel to line 2 because they have the same slope. Okay, now I can also see that these two lines are perpendicular to this line because it's the negative or the opposite reciprocal. So line 1 and line 2 are perpendicular to line 3 because their slopes are opposite reciprocals. Okay, and that is it. All right. See ya later.